Okay, here we go. This lecture is about different types of graphs that we may be using in our statistics work. I'm recording a program called Board. It's a whiteboard application on the Mac. It also is on smartphones and tablets. So you might want to check it out if you're looking for a smartboard or whiteboard, because you can share the board online with other people. So I'd like to talk about the different types of graphs that I'm sure you're aware of, but I'd just like to take a few minutes to go through several of the graphs and make sure we're all on the same page. So the first type of graph that you'll probably use in your data collection project or in a statistics project is a histogram. It's kind of like a bar graph. A histogram shows the number of times an event occurs. I have at the bottom of this page a list of a couple different brands of raisins for an example data collection project. The different boxes of raisins had different amounts of them. One brand had 30 different boxes that were sampled, and they have different numbers in each box. Brand B, there were 27 different brands that were sampled, and they have all their amounts listed. So what I did was made a histogram of brand A above the number line and brand B below the number line. You're probably used to seeing a histogram above the number line, but in this case it's a good way to show two different samples of data. So we have brand A at the top, brand B at the bottom, and there is an X for each amount that occurred in the samples. The purpose of a histogram is to show how many times a piece of data occurs. But when you compare two different histograms, you can see different information about the data that you may not see otherwise. For example, when you compare these two histograms, you can see that brand A seems to be spread out more. So there seems to be a wider range, maybe not from top to bottom, but a wider range of number of raisins in each box. Brand B seems to be clumped together a little more. There's one way down here, but for the most part it's not spread out as much as brand A. Histograms are used to show how many times things occur. But comparing two different histograms tells you quite a bit about the data. So that's the purpose of a histogram. It's a special type of bar graph. Now another type of graph that you probably have experience with from previous classes is called a stem and leaf graph. Once again, I have the brands of raisins down below, and I've made a stem and leaf graph for brand A and a stem and leaf graph for brand B. And as you probably remember, in most cases you take the highest place value of the data and you make the stem. So I have a stem for the tens place, 20, 30, and 40. There are no 10s for brand A, there are no 40s for brand A, and then you use the ones place to make the leaves of the graph. So we have 23, 25, 25, 26, 26, 26, and so on. Over here for brand B, we did the same thing. There is one in the tens stem, 17 was recorded, but there are no 30s and there are no 40s. So once again, this stem and leaf or this stem and leaf, they show you a little bit about the data, but typically the point is to compare data, to see that brand B, once again, you can see that brand B seems to be clumped together a lot more than brand A. Stem and leaf, pretty easy to make. Not terribly sophisticated, but once again, it gives you a bigger picture of the data. Now, last but not least, I know you've seen them, I know you've heard about them, I know you've used them. Box and Whisker. Good old Box and Whisker graph. Have you ever seen a Box and Whisker graph other than having to do one? Well, when my son comes home with his PSSA test results, guess how the data is shown? It's shown in a Box and Whisker graph. We need to be able to understand them. I'm not sure that we need to spend a lot of time making them, but you will see them, especially in terms of test results. Now, for the data that we have regarding raisins, I'd like to make sure we're all on the same page on how to make a Box and Whisker graph. It doesn't have to use median or mean. It does use the range, and it uses median. Thank goodness we don't have to add all these up and divide by how many are there and come up with a mean. We just use median. So for brand A, there's 30 pieces of data. The middle is between the 15th and 16th piece of data. So if I count in, it turns out the middle is right here. That's an important piece of data for a Box and Whisker. It's the middle. We also use the range. This is for the whiskers. We also use the median of the first half and the second half to help draw the box. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. So the middle will be the 8th piece of data. 1, 2, 3, 4, 5, 6, 7, 8. The middle of this half of data is the 8th piece of data. There's 7 on this side and 7 on this side. So the same will be true for the upper half. 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th piece of data. So now we have the range, the median of the data, the median of the lower half, and the median of the upper half. With that information, we can create a Box and Whisker graph. The median of the lower half up to the median to the median of the upper half makes our box. Then the range makes our whiskers. So let's see if I can draw this on the number line. We have the range, 23 to 39. I'm going to get a different tool here. We have the median, which is at 29.5. We have the median of the lower half, which is 27. We have the median of the upper half, which is 32. This creates our box. Not doing a real good job of this, but I think you get the idea. And there we have a Box and Whisker. We have the whiskers, the box, the lower box, the upper box, and the upper whisker. So the important thing to understand about a Box and Whisker is it shows us what are called quartiles. We have the lower quartile, we have the lower middle quartile, the upper middle quartile, and the upper quartile. So 25% of the data is down here, 25% is here, 25% here, and 25% here. You can see that in this particular case, the first 3 quartiles seem to be spread out about the same. The upper quartile is stretched out a little bit. So let's take a look at the brand B. For brand B, there are 27 pieces of data, so the middle piece of data is the 14th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here is the middle. We have the range, of course, 17 to 30. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 lower pieces of data, so the middle is the, which one? The 7th, yeah, 6 on each side. 1, 2, 3, 4, 5, 6, 7. There's the middle. 1, 2, 3, 4, 5, 6, 7. There's the middle. So we've split the data in quartiles. We'll go back to the graph now. We start at 17. We go up to 30. Already seeing some differences here. The median of the data is at 26. The lower quartile is at 25. Interesting. The upper quartile is at 29. We now have our box and our whiskers. This is going to be a really squiggly line. Oh, I did it. There we go. So we have a box and whisker for each set of data. Once again, this box and whisker, it's nice. This box and whisker, it's nice. But when you compare them, you can see a lot more about the data. Turns out that brand A, half of them have more than almost all of brand B. From here up is half. From here down is all of brand B. So if, for example, each brand costs the same, brand A would be a much better bargain in many cases. It's typical for half of them, like 50% chance that you'll get more than all of brand B. 75% chance you'll get more than half of all of brand B. So there are lots of ways you can compare the data when you have box and whiskers. So we have box and whisker, stem and leaf, histogram. 3 very important types of graphs that I would like you to consider using for your data collection project. But more importantly, I want you to realize they are out there. You will encounter them as a teacher. You should teach with them. You should teach about them. So I hope you enjoyed that. If you need any help with that types of graph, just let me know. We'll talk about them more in class, but now you know. Histogram, stem and leaf, box and whisker.